Like, have you done this before?
Great. I guess everyone is here, so we can get started.
Yeah.
So I just sent you guys the meta code,
Yeah.
so we can play with it. So basically, we have two tasks. The first one is create a video, like the one you see in the lecture presented by David. And we also need to add a comment to each line of the meta code, so that you can understand what's going on, what's the physics.
Well, at some point, my editor page and my command page flipped.
I kind of like that. Mine's not.
I don't know. I did it on accident.
I kind of prefer it like that, though. I don't like it like this. I just don't know.
I'll give you a brief introduction. So basically, this is a wave function of stationary state for the particle in a box. This N, this is just your quantum number. Here is A. This is the mass of the box. So basically, if we know the quantum number, we know which state or the energy of the particle. So the code here, psi1, this is your ground state. Psi2, this is your second state of the first excited state. So for ground state, first excited state. Makes sense, right? Does anyone know why we cannot have 0 as our quantum number? Any idea?
Why we can't have 0, you said? Is it like a non-existent state? Like it can't exist in something where it's equal to 0?
Well, just look at this equation. If n equal to 0, then this wave function is 0, right? Then what's the meaning of that? That means
There's nothing.
you cannot find a particle inside the box. The
Oh.
particle is not existing.
Hmm.
So which is not physical. That's the reason we have to start with n equal to 1.
So then if n were to keep increasing, you would go into like the second excited state in that, or does it only?
Yes. So everything except the ground state is excited state. And actually, we do know from this equation, we can know the energy. So we can say the energy also depends on the quantum number. Basically, this is only unknown. right? So this is our quantum number square. Pi, we know this is constant, H bar is also constant. And this is just your mass of your particle inside the box. A is just a mass. So everything is known except for quantum number.
Can I have a question about the X second line on X, the second line? Yes, I do not understand when you said X equals 0 to 100.
So I guess right here, this is just a math entry. So what we are doing is we're creating an array of numbers. Zero is our starting number, and the L is our ending number. So we are at each step, we increase a little bit by this amount.
Okay, so 200 is the maximum.
What's that?
Is 200 the maximum of L?
Increase
Just
it.
increase a little bit. So
Increasing by.
the first number is zero.
Ends
The
at
second
L,
number is
and it's increasing, like each increment is L over 200.
that's right.
So he's first year.
I guess in this specific setup, so we have a linear combination of two stationary states. So the total wave function x two
Yeah.
So this is our initial condition of the wave function. This is just the expansion coefficient. 50-50.
I didn't get the question. You don't ask the question.
Do you have questions about that expression?
What is T?
At time equals 0.
T equals 0. Time equals
This is just time t.
equals to 0.
That's for the like initial state.
Yeah, this is our initial state. All right. If we want to know our future state, we need to add a time evolution period.
Does the equation you wrote down, does it correlate with what we have with line 3 on the This is it derived from line 3 there?
This is just our initial setup. We can prepare the initial condition in many different ways, but this is the initial condition we choose. So we put 50% particles in the ball state and 50 particles in the content state. So we can do that by laser executions, right? Does anyone know the meaning of this one?
Well, that would be like the change in energy from. Yeah. So there would, it would be. I don't know. It would be, there wouldn't be any difference between like going from the ground state to the ground state. So that would just be either 1 or 0. Right? Like equal to the ground state or like 0 if it's like the difference between the two states.
But I guess we can go back a little bit. So what is psi?
Wave function.
Yes, so basically here, this is psi square. What's the physical meaning of psi square?
What?
Physical meaning.
The psi squared. I actually had that in my like presentation. a
You
while
have
back.
that written out somewhere with the wave function squared is equal to. I don't know, I think so.
I don't know where. That's kind of ring a bell.
This is just your probability density, right?
There it is.
So here, this is your ball state probability density. This is your most excited state probability density. You know the meaning of this symbol, right? This is just tell MATLAB to do element-wise calculations.
If you said the first one is the ground state, our probability density, 1 is the ground state. And you said R22 is the first excitation state. What about R12? What's it?
Yeah, that's a tricky part. But I don't know what's the meaning of this one and this one. Why we have these two terms.
Like ground state to excited state.
Why we need this term. It has to be a reason, right?
Would it represent like the probability density as it is transitioning into a different state?
Close, yeah.
Okay.
Yeah, it is.
Oh, I guess, yeah, we should, because that's like, I don't know, at least like that's our homework. To turn this back into like it's on, so I should be it.
Just that one of them goes like from ground state to excited state, the other one goes from excited to the ground state, and I don't. It should be, energy should be equal, but all of a sudden. Right. So,
So Suppose this is our initial state. We'll have a linear combination of two stationary state, right? C1, C2, just expansion coefficient. So what will be the probability density for this wave function? Still C squared, right? So let's make everything simple. So we just assume C1, C2, Psi1, Psi2 all real. So we do not need to worry about complex conjugate. So that's the reason we have this.
Nice. That sounds the third term, the note that you wrote under the third term, should it say R21 or R12? Or should they both say
Oh,
U1?
my bad. Thank you. In this case, these two are equal because we assume everything is real. There is no complex number.
R12 and R21 is equal.
In this case, under our conditions, they are equal because there is no complex number, everything is real. So if it is not real, then we need to rewrite our equations.
I'm gonna forward you an email about our analytical lab TA's first year seminar.
Okay, Shelburne.
No, Zoe.
Oh, sure.
I'm not including myself.
So in this case, they are not equal, right? We have two terms. Maybe and also if you run the method code to this line, it generates several graphs, right? And we do call R12 and R21. If you look closely, they coincide with each other, which means they are the same.
Why do we have, why is it like X and then R11, X, R22, like why is there X in between each one?
We just want to put everything in a single line. So basically, X is just your x-axis.
Yeah.
And this is your y-axis. So the meaning of this command is we plot
Like instead of X, Y,
first.
XR2. That's the line, instead of plotting X, Y. You just
Oh,
plot
Y.
X against the probability density.
And then it just does that like four times.
Yeah, well, then
Is
you
that the
plot
last
X
row?
against all four.
Yeah.
You're just graphing all four probability densities, like I don't know what that would look like, but it would be like a line on the graph, right?
Yeah,
Would you put the same value for X throughout?
that-
Would it be the same value for X throughout when you plot them?
Yeah.
Yes, the same value for X.
both
If
actually the
it's-
same line.
Yeah, okay, the ground space.
This is our initial X.
Yes, the ground thing.
Yeah, it's the same.
So X is like the x-axis,
Yes.
but it is measured
Zero
as
to
like
L.
L is like the amount of x-axis that you have. So you are plotting the probability density against these increments of L. Every 200th L, you have like a new point that comes up, right?
Yes.
All right, so what exactly are R12 and R21, like R12 and R21? What,
It's just the term and this term.
okay,
Then we generate the figure of probability density.
Oh, no, I can probably just take away these, so.
Until the second pause. So
Yeah.
I've just been typing this in the editor. I haven't actually been in the command window. But with all of this stuff here, plot that's what we're looking at.
Probability density.
Yeah, that's the one.
The first figure is this one.
Oh,
So you are just plugging the weight function of your ground state and excited state.
Oh, you went too far.
And if you enter, if you hit enter, then the second figure pop up.
oh,
Figure that.
Oh.
What the?
Is that, but it's also, so
This is your first figure. First
that
figure
was
is,
the first figure, yeah, but it
this is for the
also,
weight function.
it also popped up when I tried to plot the last part as well. So,
that's all.
by the way, oh, wait, never mind.
So this is
Okay.
first, this one's first.
This one is second. So it's probability density.
Wait, so then I went way too far.
There's something before this.
So for your probability density, how many lines do you have? Yeah,
Yeah. There's R1, 2, and R2, 1 are the same, yeah.
yeah.
Okay.
That's our point line.
So how do
With
you
about 12 lines,
know which one is which?
only 3. 2 are.
Huh?
That's a good question, Brad.
Little, I was trying to do this earlier. Right up the board. That's first, second, third, fourth.
So remember, this is your wave function. Right?
Working on this.
Just hit enter again.
This is your shape for the ground state.
Okay.
It's your first excited state. This is a wave function. But probability density is wave function square. Something like that.
Get that first figure in this one. So there's like our. Like the ground state, the excited state with two peaks, but then there's this one. I guess it kind of does look like that. It's just not as sharp. Down here.
This dash line.
The dash line. would
This
be-
is R21 or R2.
Okay,
Everything in this figure is probability density.
okay. Oh, because now it is squared.
Yes.
And, okay.
Since it's squared.
Any question?
AVEX equals to 0.
This is just the average position of X. For all particle inside the box.
Well, you said that it can be 0 inside the box.
What's that?
It's like
You mentioned earlier,
quantum number can be
is
0.
0 inside the box.
The quantum number cannot be 0. It has to be integer, starting with 1.
Quantum vibration at the beginning,
Yes.
when you ask the question. When you said that the,
The particle has to be inside the box.
yeah,
It can be anywhere, but it has to be inside the box.
yes. So why is the average now 0? If we have 0.
There is no data meaning about it. We just assign this variable to an initial value of there. And the meaning of this variable is average relation.
Okay.
AV stands for average.
It's just an assumption. It is just an assumption.
Yeah, you can give it to another element.
Is the capital T equal to 1? Is that time?
Yes,
And then why do we switch to little t?
we switch to
Like
one.
for little, the little t equals from 0 to 3. Big T.
Like your total time that you're looking at it. Right, because like little t is like the time that you're at, but like big T is just like big L. It's like just the range that you're looking at.
So
Which
when-
one?
Big T is like goes from 0 to time, the total time it takes is 1. Just 1 time,
So
and you're analyzing it by increments of like 1/100th of that time.
That's
exactly.
Seems like you did know.
I guess I did.
I know why we need this problem, why we need the time.
Because. Why is that? It'd be like impossible to say where it could be. If it's like infinite time and infinite length. Could be anywhere.
So you
You
guys
need to
start,
have like a bounds on your problem to come up with any sort of. Not general, particular solution. Maybe.
There's a question mark at the end of that
I
statement.
don't know.
Time independence.
yes. How can we get the time dependent sorting equation?
Oh.
That's,
Is it probably equation, right?
it's not just establishing that function.
It's just the, in that equation where, we were talking about earlier in class, You know, the one that was written like
I
three
don't
different
know,
ways, where it was like, oh, some of the, I don't know what we were talking about. Like energy or what, but like 50% of it's here and 50% of it's here, it's like, yeah, you were just talking about that earlier. Make it different. Gosh, hold on.
I think they're just.
What was C?
It's like our have independent shorting equation lines. For the stationary state. So this is independent shorting equation. And then this is. We have time. Within this equation, we can evolution of wave function at the function of time. What?
Here. It's here.
In the code.
And
What is R11?
what is one?
What is this one?
Probability density.
Yeah. Well, it's it'd just be the average probability density then, right?
So like I said in the beginning, our initial condition is 50% particle in the ground state, and 50 in excited state. So we have one half, right? 50 in the excited, in one, 30 in the excited state. Anyone understand what's the meaning of this line?
Was that the part that you were saying was the time independent Schrodinger equation?
Yes, pretty close. Why we have this cosine term?
Why do we have that part you said?
Yeah. Why we have cosine?
Good question.
Because the, I don't know, sine of zero is zero. Because if t equals to zero, that would mean at the ground state, that would mean that will make everything zero.
Yeah, but still, that does not answer my question. Why we have this cosine term?
Zero is one.
It is one.
Yeah,
I don't think that's the answer, but.
that's the fact with the cosine of 1, 0 the other day. That's what I was missing.
I don't remember any of it.
It's not right. Oh. Then I was like, yeah, it goes like one. I'm two. I'm 2 0 0. Yeah. So sorry, which is like not from one of some. Yeah. If you I'm blessed.
Yeah.
0.5.
I'm blessed.
Where's God?
You know, that happens.
So this is our initial condition at times 0. And at any other time. So we need to do the probability density.
You think we're making an animation that was in the PowerPoint?
I was trying to figure it out. No, because you have to upload it to YouTube and then add the link to Dimitri when you send.
Right, this is our probability density. Let's multiply each term.
See. So. No, I squared is negative. Squared is the second one.
Yes, that makes sense, right?
Yeah.
You never told us about your gross real needs.
Well, I saw pictures because I didn't want it to be on the recording.
We also use this assumption. We can cancel this.
Oh, yeah.
You can cancel sign, so I left it with cosine.
Why is the code, the line of code not two cosine? But, yeah, two cosine of two pi t over t. Cause it's cosine plus cosine in your equation. Which would be two cosine? Yeah. Yeah.
Yes,
There's also two of those. E.
Oh. Well, but they have different powers though. So you wouldn't be able to add them together.
here,
No, it's.
one.
So then the C1 times C2 being equal to 1/2, that would cancel out the two.
Yes,
Okay,
Always a connection.
yeah. Always something that I don't know how to do.
There's always something.
Oh, which makes sense that the R12 isn't multiplied by 1/2, because that's the one that cancels out the two from the cosine.
yes.
Okay. Got it now. Oh, yeah. Math.
That truly was a question that was just then.
So smart. I'm so mad that I'm so much better at math than I am at chemistry, because I don't like math. Because that's not what I'm going in for, right? But I'm so much better at math than I am at chemistry.
I hate math.
There's not minor.
Yeah, I don't know.
That's right.
I thought it was really cool to like know more math. And my classmates in like middle school.
Yeah,
and
me
then
too.
High school, I'm like, no. I hate this.
Since this is your. This explains why we have a cosine in the code.
Oh. Yeah, this is making much more sense in my noggin.
Yeah. Well, there's a chat.
Someone chatted. Probably Sam.
It's probably Sam asking about not being able to see the whole board. Yeah, it is.
Why did you like get it exactly?
I will send him a picture of the board. And then he will be able
Can you
to
send
see
me a
it.
picture of the board?
Yeah, I'll send it to the group chat. So much. Here you go, Sam. Why did it autocorrect to a point? There we go. Now Sam can see the whole board.
So basically, for this line, we just use this equation. At every time step, we recomputed the probability density.
All right, so.
close to the end. Yeah.
So.
I never know the medium of this one. Of this one.
The AX.
Yeah. It's X.
Capital X, the position of the particle?
Yes.
Basically, why the medium is.
Is that
That's
the complex, the transfers, complex conjugate transfers?
Yes. Why we need that?
That's a good one.
Well, the R times R prime would give you the an identity matrix, right? Is that how that works? Or are the R's not matrices?
This is just a probability density.
Yeah.
For each position.
Oh, I see it. Oh, what's the derivative of a function in a graph? When you're graphing just like polynomials, the derivative of something is the slope of the line. The slope of the line?
Yeah,
So then
And then
that would
it goes
just be,
yeah, but does the apostrophe mean that you're taking the derivative of it?
oh, no, that's right, it
No,
does
the
not. It
apostrophe
means
is
the-
the complex conjugate
Yeah,
transfers.
There's everything very, so what I have to do is just transpose. Previously.
Oh, the apostrophe means transverse.
Yes.
Okay.
Transpose.
Transverse.
Transpose.
Transverse.
Transpose is it is the transverse. Transpose.
So it's the complex conjugate transpose, right? That's
Yeah.
what it's called.
Okay,
The previously is the
First.
real vector, now you have column vector.
I'm pretty sure those are completely different things.
Probably. Meaning this one is the transpose and you're thinking of something else, Frederick.
Well, if you transpose something, you like put it onto something, right? But if you transverse it, you like reverse it, pretty much.
I'm not sure off the top. of
I
my
know
head,
like
apologize.
copy, this is unrelated, but like copy and then when you paste something, transpose it like from row to column. It's transpose. That's sitting there because he dropped. So what's
You want it.
But I don't know what transverse.
I think this is the transpose.
I really have to dig through my brain for that one. I'm not sure.
Yeah, I don't know, I can't really explain it,
situated
I don't
extending across something. A transverse piece.
So. That's the dimension of X is.
Linear here. Oh, there's card.
What do we do here? You have a prime. Oh, we can do the matrix multiplication. X times.
Matrix notation. It's like 1, 2, it's like 12. Yeah. Should we look up? So, yeah, it's just next to each other.
Basically, you get a single number. What's the meaning of this single number?
the number. X or what,
So physical meaning.
like its position? No, no.
Yes, it is approximate to its position. What position? What kind of position?
The position on the wave function. Like the position of a particle on a wave function. Ooh,
But why you need this matrix multiplication?
It's just what you do.
is it? Is it like the vector of the particle, like the direction or velocity that it's like moving in? Oh, no, it's just a number, yeah. I'm trying to think of
Yeah.
what matrices would have to do with.
It's average position.
Yes, exactly.
Oh, Fred,
Oh, that is average position.
So at each time step, we computed the average position of particle in the box.
That's.
is it specifically?
X, A, B, E, X. Cause that's where we're doing the
Yes.
matrix multiple, okay, yeah.
Does it specifically have to be a particle in a box? Like, is there a difference? For a particle in a box versus just in free space?
Is defined as 0 up here.
For our setup, this is particle in the box, right? Because we,
Cause I'm sure something in like in free space would be infinitely more complicated than this.
So
Cause you don't have any bounds for any of
if
these.
we, already defined A X as 0 up there, like after we said T equals 1. Are we saying that the result of that matrix multiplication is always going to be 0?
the initial value doesn't matter.
Okay,
Oh, that's just the initial value.
Yeah, we just put the initial value here, and then at each step with the pad,
Yeah, it's
we put the new value into
oh,
the
you,
matrix.
so first you put 0 into that matrix
Yeah.
to multiply it, and then you just continue on.
So
With, wait, no.
we do nothing to the initial value, it's just the initial value.
Okay, all right.
We do not do any operations on the initial value. So we create an initial value, then we compute the average utilization. And then we combine them together
Okay,
into a single file.
all right.
Does anyone know why we need to do this kind of trick? How did you calculate the expectation value or average value for a continuous variable?
We need to set bounds for it first, right? We did.
Yeah, what is average value for X? What's the equation for that?
Just.
This is our equation. And we have a continuous variable. And here, they're not continuous, they're discrete. We have to do. For each position, we have probability density. We multiply this position with probability density, and then we sum up them together. Any questions for? Okay, so the next step is just pretty straightforward, right? We do the same thing for S. We just store this into S, making it a new file. Then we do some plot. Because this is where we need to create the video. Share with you. So by the way, you can see the animation line from your final app code.
You're asking if we want to see it?
Are you able to see it? From code, just hit enter.
Try to play,
Oh, I need to save it first, actually. Or I could just copy this.
Yes,
Oh.
yes.
Oh.
Just read it and code it.
Save it, and then it switches immediately to this time as well.
it switches.
So like a solid graph.
So the,
Didn't, there was literally a whole like part of class where we did that, didn't we? We saved that video. We saved the video on the thing and put it on YouTube.
Yeah,
So
how
should
do
be
you
able
do
to
it?
that.
We'll have
Do you know how to do it?
Yeah.
Yeah, me
We've only
neither.
done it once.
Frederick, what if you just don't include?
I'm calling it. You better not call me by my name.
so the movie is just a evolution of probability density.
Yeah. Oh, that works, but it does stop eventually.
Oh, but it stays up. Oops. Oh, mine didn't stay up.
Untitled one.
So at pause 0.01, like right at the very, very bottom. What does that mean?
So yes, it's just that you wait for some period of time.
Okay, all right, that makes sense.
But they do it quite before it stops.
Oh, now it's just freaked out.
Figured out how to do it.
No,
Save this. You have to like, you have to do that for one of our. We have to. Just save that, upload it to YouTube. That'd be nice.
see what I wrote. That one, I just wrote. Complex conjugate transpose.
Not the second one. Not AX equals to this R.
Oh, okay, well, then I have it mixed up, because that's what I wrote in the RR. Not the second one.
You get. You get your hand.
You just click run.
Yeah.
Oh, I think I have some here.
So the grant text just help MetaLab to create a video and store it in your local computer.
Or just in. Oh. Invalid expression code. Why? Don't think. So this was the very last thing you typed in red. And when I tried to hit enter, I got this. Did I include all the way to the bottom? Or should I just get rid of the second?
It's maybe your new code. There's no with the static.
I don't think so. You didn't have to write the red stuff in there, right?
That's just to make the video.
Oh,
Because without the red stuff,
Oh, yeah.
it makes it like just a picture file. It won't upload as a video.
oh, okay.
But with the red stuff, it kind of just doesn't work. Then I tried it without the very last one, and I got even more errors, so. Spencer and Wyatt are gonna be at the thing that Melody's gonna be at. What is it called?
They do symposium.
Yeah, that was
I
it's good crap.
totally embarrassed myself in front of all like the Japanese students and faculty that were visiting. Because I went into class like earlier today in art and oh, actually, no, this was after pecan. So I literally just went in to get some Swedish fish. And I walked in and they were all like standing in the lobby. And I was just walking past them. And then I swear I heard somebody say my name. Like they were like, Brad, like I heard it. So then I like stopped and I'm like, I just like looked around, like I just stopped right in front of them and started like looking around, like the crowd of people, and I couldn't see anybody, and then I just
Oh.
left
poor
and walked.
Brad.
All right.
You guys received my email?
Yeah, I'm trying to.
Thank you.
All I have to do is keep hitting enter. Oh, yeah, warning, no video frames were written into this file. This file may be invalid. That's what I keep getting. Mine does not say that. You did. Cool. What is different about mine? I have no idea. Okay, now let's save it as a .fig file. Okay, but then I can't open this file. Oh, where'd it go? Like it makes that, I don't know. I have the right one. Right slash. 63.
I don't think I've.
Just a little thing, but then when I try to.
It looks like that, but I can't even pull up anything right now. I'm trying to run it. And I'm not getting any graphics. Like the moving
Like it just don't.
wave that was in the presentation. And the lecture.
Where's my new video? Uh-oh. What? Spinning the middle of it down. I tried with that. Oh, so I have to like drag it in my desktop pretty much, but then it doesn't want to open that way either.
Yeah.
So I'm seeing if I can just put it in change.
Oh.
Wait. Let's try it. This work? What is this? Particle in a box. Dragged in. Okay, video editor, just stop trying to.
Ah,
Did it work?
yeah.
What the heck?
So choose a thumbnail.
Thumbnail.
Three options.
No, this is not made for kids.
I said that mine was.
I don't want kids to see this. Sure. Here. Okay, it's fine, I love. Press B. Sam is doing. Did we make this public? How did we do this?
Yeah. Mine is working out.
Oh, yeah, I made mine public.
How? Come here and help me.
No.
Did you copy
Yeah,
it?
I guess I
The thing,
have
the
it.
email that he just sent?
Yes, I copied it exactly.
Yes, okay, and
I
then.
tried it both times. So
Did you
there's-
start running it?
There's in one of them, so the first red text that's up there, the vid ob
Got,
open,
got.
in that one, it's before S. And in the email, it's after S, but either way, I tried it both ways. And it's just not running at all, like I'll click run. And nothing comes up at all.
Yeah, sometimes it like plays too much, so then I exit out if this is saved to reopen it and then try it again. Yeah, then you have to like click enter and it will show different graphs.
Oh.
Okay.
Alright, alright.
And then that, and then it has to keep going.
Ava, where did you go to upload a new video? It's like on YouTube.
So it's running out.
Oh, you do click on it.
Okay. Well, How do you
Yeah,
make it
last
into a
summer.
YouTube video?
What?
How do you make it into a YouTube video?
That's saved on here. Okay, then go to YouTube. Or like save this to your desktop or something.
Like the
Save
whole
the,
code in there?
no, the AVI file. You need to like save that.
Oh my god, mine's freaking out.
I don't know, I drag to home screen.
You need to like right click.
Is this what I'm in now?
No. Right click it. Or. Okay,
Oh,
sure.
shit.
Yeah, and
Oh, it is in there. Okay, cool.
go to YouTube.
Yeah,
and-
okay. Got it. Thank you.
You're welcome.
All right, you get that? You have the, try to run it again and get to the, did you copy the red stuff in?
Yes.
I would try to run it again and get to the, wavy
Changes.
stuff. Or if,
Actually see if this works. Cause it was like, wait, let's see if it works. It was freaking out.
It's like all the files that you like.
Oh my God, it's working.
So,
That's amazing because it was like,
so that just,
it was
So
very
this
upset
running right
in the
now.
little screen. It kept like, Like,
is
flickering
actually not
right
on
there.
yet.
Yeah.
If I run it again, I think it's going. It says it's trying to go.
Views. Someone's watched my other one 33 times.
Yeah, wait, my spiral one has.
My spiral has 33 views.
That's so much.
Ow.
Mine has 10, which is still a lot because like who is watching this?
33 times.
3 likes.
Yeah, it's
Well,
coming up here.
penis.
There it is. And then this AVI file popped up as this was.
That's
playing.
Yeah, that's what you
And
call
this
the
is that
collab.
file that
Yeah.
I dragged.
That's what you got.
That's why I'm trying to
I feel like there's a video.
Or you could probably just save it anywhere else. Keep it that way.
And I'm like, that's
That's true.
But it's
Like, you
harder to
can't
not
complain
be
about it.
here.
Yeah.
So.
I have 2 likes. I think one of them is Dimitri though.
Yeah.
Cause he said that he would like it and subscribe to
Yeah.
Wait, yeah. Did it say I have 1 subscriber? Honestly,
Yeah, I do have 1 subscriber. Wait, I can't see who my subscriber is. I don't
Probably
know if
him.
it's Dimitri.
He subscribed to all of us, but
I know.
we did it first, so he's your only subscriber.
Yes, we are pretty close to finish.
You think it's done?
I think so.
See?
Yeah, it's kind of wonderful.
All right. What are we gonna call this particle in a box animation?
Yeah,
Close,
what's
like close, man.
waterfalls is the.
Sorry, not loud.
Colorful
Thanks,
things.
so yeah.
Are you just copying and pasting the code into the description?
I never do that.
Oh,
I don't want people to know my secrets.
all right, well,
My secret recipe. They gotta code it themselves, even though we fully copied it.
Yeah.
But you know, the public doesn't get to know. It's further on there.
Yeah, but. Sam.
Well, what, does Dimitri
Sam
want
said-
copy guns? Oh, decline.
Unless that was an accident.
Oh, no, he called just me.
What?
I just got a text saying, what is Angie Craig up to?
There it is. That's what I wanted. I screenshot that. So I had it. Probably should.
You guys getting the last figure for the average position?
Yeah, the colorful one.
There's one after
Colorful
that.
is waterfall, the next one,
Oh, there's one.
Waterfall's the colorful one, and then there's one after.
yes.
Oh, there it is. Ava, it's the one that you saw. Yeah.
Screenshot.
I don't really understand why we need to divide average X by 100.
That's. I'm getting a vague answer for me too, because whenever I text him directly for questions, he gives me the vaguest answers, and I'm like, this does not help me at all. Thank you, Sam.
Are you come to class?
So I'm trying to make it use. That is. I don't know what you meant. Or is that not what you meant to say?
It's not.
You're welcome. Huh?
So this is like a whole matrix, like these two lines together. The S and the RR, S is, sorry. What do you?
That's fine.
That's
Solid
for. Have X or, oh. I don't know, I just said the probability density applied to the initial.
Yeah, I don't know.
Related. No.
I know respect class, but.
We said S was,
Kind of class, unless
yeah, the initial state where it's 50% excited and 50% ground state. So I thought that like R up there is the probability density, like that describes the probability density, like with
Why did it do that?
Right, like
Oh,
as a
because that's
function.
kind of here, that's fine.
so then S being your initial state, if you like apply the how the probability density changes to the initial state, that should give you like the probability density like at the X that I don't know that I don't know.
Thank you.
Yeah, okay, I mean, like, I think I kind of get it, but like, not really. I mean, but then I don't know how to like describe what that product is, like in words, like that is the probability density at that very moment.
And I said my eyebrows really big eyebrow. It's only because it's kind of.
Because R is like a function of time,
That's
right? But S is
That's eyelashes too.
S is based off of the like the excited state and the ground state at hold on, I'm trying to look through all this to like
Got it, friend.
to bring it back.
So smart. You got it.
But that's only based off of distance. Like, because up here, all of our size, that's what you multiply the size to get the R value. And then
Unless she's.
the R11 and the R22, that's what determines S. So that's based entirely off of position. Then the RR has that cosine 2 pi times time over like the percentage of time that you've gone through. So then that's how it has like evolved over time. So then you multiply that by the initial state to get the state like at that time, I believe. Yeah, that's, my brain is tired.
Said it's saved only as text. I don't know, Sam.
I
I'm
don't know
sorry.
I don't know how to fix that for you.
Man, if only you like, ask him what he's
Yeah, only
why
came
he-
last.
like. I mean, he can make it here at 11, right? So.
You asked. No, I tried to explain it to him,
That makes sense.
and he said it's saved only as a text. I don't know how to. I don't like.
Yeah,
I'm not sure then. I don't know what. Sorry. I don't think I screenshotted all of my graphs. He said, it's okay, Dimitri will understand. For anyone else.
Okay, folks. So last question. Why we need to divide this by 100?
We also, we said that little t would progress in increments of like 100. But
Yes.
I don't,
Why we need to
is
do
it
that?
related to that?
I can only think that it somehow cancels that out, so it gets plotted correctly.
What's the critical meaning of that? What is
Is it
the,
just that time is equal to 1 at that point then? No.
what is the relationship between probability density and probability? Well, can you convert probability density to the actual probability?
Just by taking the square root of it?
Is a probability density, right?
Yeah.
If you are looking for probability,
Oh, it's the derivative.
you need to multiply dx. The interval, right? This is density. Yeah. Interval. So what is the interval in our setup? Yes, sure.
There's a way I can go back to the previous graphs that it showed me. I mean, I did it, I think so.
Well, then there probably some other way.
So I have. Screenshotting all my graphs. She's finishing the homework. The Friday homework? It's literally just what we did today.
Oh, yeah, I thought we just had to, upload that to YouTube with our, script and comments and turn that.
Take screenshots and print them out of each, the progression
Okay.
of each graph that it produces.
Yeah.
Please bring the grass out.
Yeah,
I don't think we literally have to print them out.
it says,
We just
have,
have
it
to save
literally
them.
says print them out.
All right. well, print-
Read from
I
the
did that.
course, I mean, I know what you're supposed to do, but
Hey,
Provide printed
my graphs look
graphics.
exactly the same as everybody else's.
I don't know,
no.
I don't, it just says provide printed graphics.
All right,
Fred, this entire class is effort based.
I emailed him.
Yeah, Fred, this is effort based. If you don't put the effort in, it will stop being effort based. And then you're kicked out.
All of it stops being.
No,
It's-
then it's skill based.
Stop putting in effort.
You want
Then
this
I'm
to be
fine.
skill based?
Sure,
No.
No.
I'd rather have it
I need
be,
to email him my video.
because that was my problem with high school is that
Vetoed, Fred.
you have to put all this time and time and time into it.
What, you're
No matter
gonna put
whether-
no time in if we have to actually solve all these things by hand? You'd put time in it to figure out how to do
What
it.
are you talking about, dude?
Dude.
What are you talking about? You're saying you don't want it to be effort based.
Yeah, because then you have to try very hard. There's not a way to do it without trying hard. Like, if there's a way to easily do it, then I'd rather do that. I'd rather just be able to do it. I'd rather be able to do it than have to prove over and over again that I can do it.
Same, but I
Yeah.
can't do it.
Yeah. I guess it depends on your situation, you know? If you can't do it, if you can't do something, of course you want to say
Yeah, that's what
that,
I'm saying.
oh, don't look at whether or not I can do it. You know, oh, I'm trying really hard, so
Yes.
just give me a chance, right?
Yeah,
But then
that
if you
was-
get it, if you can do it really well, you want them to say like, oh yeah, you can do it really well, like, that's good, rather than saying, okay, like, why don't you do these 100 problems, like, to show that you can do it, you know?
Yeah. I see. We're on the same page.
All right, we better be.
Sound fair? This was part one, folks. Part two is due on Wednesday. It's like an action. Due Wednesday. Part two is due Wednesday.
For some reason, I thought it was a Monday, like earlier today. Really don't do peach hour over the
Yeah,
weekend.
I'd be like, that's not gonna get done, cause I need to.
Probably an
Shoot it
analytical
all.
apartment problem.
How come sometimes my airdrop doesn't work?
You trying to airdrop me something?
No, I'm trying to airdrop myself something.
Really. Apple feed.
Well, now I just know it's my son, it's the ideal, but.
Any additional questions?
I don't think so. This was
Oh, yeah.
quite well.
Yeah, thanks for
Thank you.
walking us through it all. Yeah.
Yeah, kind of a lot. Yes, thank you to our classmates who attended class
like
Yeah,
animation,
in person.
Whatever comments you made on it.
Yeah,
I-
everyone else.
I uploaded
Negative.
See you tomorrow.
my animation.
Negative shout
Yeah.
I just- Oh, yeah, so I saved, that file that I read.
Disrespectful, you shout out.
I just on YouTube, we did it like earlier in the semester. Went to like, you upload a new video and it's like, it's pretty explanatory. You just pick your file and then you make a title. And then I just copied and pasted my script with the comments into the descriptions.
Monday, something like that.
If you have like a Gmail
I like that.
account, you already have one. But yeah.
Oh, I think that now I'm literally in the printing building.
I don't wanna
And
do
then I
that.
do something.
Mine's ready to go.
I'll go to the, oh, mine's also not ready. I still have to like put my pictures. on.
Yeah, so.
What are the printers called around here? What building are we in?
Yeah,
No idea.
it probably won't show up.
Oh,
like
there's
that. There should be like a
There's, like,
bunch of
two
them
up.
here. It's literally the computer center.
This is in the
building.
lobby though. We're just gonna try the lobby.
So if you go, if you click out of that thing. The thing that's hanging down, if you just, yeah, click like, just get rid of it. And go to here.
I asked him if he had any questions.
No, that one next to it, yeah, that one. To create, upload a video. And then if you haven't done it before, it might ask you to do stuff first. Oh my gosh.
These.
I love that
these.
you're plastic bottles.
And there, white claws in there, some kind of, oh,
White.
yeah, it would look like. You know, this
I guess
like
that's-
sparkling water cans that look exactly like Celtic cans.
Yeah. The.
I love the idea of people just drinking white claws in here.
No laws if you're drinking claws. Fred, do you wanna see the reason I don't wanna live in my apartment? Yeah. And it just gets worse. The more you look at it, the worse it gets.
If,
Those are my dishes.
that one is
I
just
made
like
this
the
morning,
graphic.
so-
Okay, the
so
dishes
if you go back to the.
I could